live demonstrations.
Hey. Yes, I actually have slides this time. If you guys were here for my last Duke co-op, then yeah, I had really crappy slides last time. But anyways, I'm a really bad public speaker, so go ahead and speak up, whatever, if I forget something. Normal.
Good on you for trying, though.
Yeah, you know.
There's no judgment here.
This is one of the subjects everybody, I just started a new job recently, and a lot of guys were, a lot of the stuff is like, they're all like PHP programmers and not a lot more front-end stuff. And they need to move a lot of data right now between a bunch of different systems and like Peachtree and crap. And so they were always asking how I did everything so quick. I'm just like, oh, use Node.js, and nobody know what it is. Hardly at all. So one of the things I decided to do this talk on, and a lot of people always ask me when they go about it, they want to know how to, everybody always wants to know how do you take care of all the cores from having a multi-core processor, because Node.js happens to be a single thread software, basically. But anyways, everybody always asks why I want to use Node, and well, it's fast, it's really scalable, and I can put it on pretty much anything really quickly, depending on how you write it real quick. I mean, I usually develop it on a Windows PC, deploy it to a Linux server, and then sometimes use my wife's MacBook. So it's the same code across everything, just at a different install of the actual framework, whatever you want to call it. So, and it's simple. I like simple for the most part. Yeah, is it single threaded? Yes, it's always single threaded. Everybody always asks me, well, it's asynchronous. Well, how does it kind of work? It's the best picture I found describing what like the event loop in Node is, how having to do callbacks and stuff. And the one thing to always remember too is when you do like a set interval or anything like that, it's not going to always, it's not exactly guaranteeing that it'll be happening on that time. So if you do a set interval for 10 milliseconds, whatever, and console out hello world, it's not always going to be on there. It's going to be queued at that point in time on the thread, and if there's something ahead of it that's like big, like you want to write a gig file or something, is ahead of it in the queue, then it's going to have to wait before it'll actually do the hello world until you're done with the gig file first. So that's another reason a lot of things I get, like, well, why isn't this doing this when I think it should? It's like, it's weird because it's asynchronous, and a lot of times it won't do what you think it would normally do. But sometimes you want to know, it's definitely got the big, why is this working, or why isn't this working thing going on a lot, and I don't know why. But it's fast and it's good, and no, it has nothing to do with Java. I get that one all the time. It's, yeah.
JavaScript.
Yeah, it's JavaScript. But anyways, there's two main ways to use multiple cores, and they're both really easy for the most part to do. They're just, the first one up everybody finds is cluster. Which is basically designed to share loads for like heavy load websites across multiple cores. So like if you're getting someone that's getting a lot of traffic, you know, thousands and thousands of users and stuff like that, logging in, logging out, stuff like that, then you're definitely going to want to go cluster out for that. But it doesn't. But the tends to be if you need to do a lot of like data processing and stuff like that, like you're copying databases, writing huge files, stuff like that, you're going to want to go the fork route usually. I'll show you why here. All right, so we start off with cluster. What you're basically doing is making like you're forking it, but you're starting up a new Node.js process of itself, which sounds really weird, and it kind of is, but it's basically just starting it up so you're another server listening on the same port at the same IP address as your other server, for a web server example. and it kind of load balances across the different servers you guys are running. So yes, you're basically, instead of running, you're basically running a server on every core. And that just happens to be listening to the same port and the same address and uses the same encryption and everything. And you load balance it across there. So this is a quick example I just copied down. I did real quick. Basically, the code on the right, all it is just a little launcher script. Code on the left is the actual module that you're going to pull in here and start and everything. And to give you an example of what that looks like, you see just console logging, like it's the master process or it's not. If it's not the master process, it just launches workers up into how many cores there are on your PC. So all right, so to give you a quick example, it just looks like this. All you can see is when you're on here, it's kind of all over the place for one thing. It's not generally set, it's weird, like I said. But you also notice everything gets console logged. You only see I'm the master one launch first, because that only launches once because there's only one master process going on there. But all the workers will launch, you'll say I'm the worker, then there's before and after fork multiple times and stuff too. That goes the wrong way. Anyways. But if you look on their sources, like before the fork, I'm the worker, and after the fork, all that stuff, and then the launching cluster will go all the time too, because you're just making a new copy of the whole application going across, not just the bit you think it is going to be. Trust me, the first couple times I tried to do this, I was like, why is it doing the whole thing when that's what it was supposed to do, because you're supposed to be sharing it across ports and stuff like that. But give you an idea, it'll have something like this on everything. So like basically it'll have 3 other servers that'll run. The master will just fork itself up until the number of CPUs you have. So you'll have the 4 servers all listening and 4 sockets all listening and everything on the same ports. And it'll load balance across those. Depending on the needs. But anyways, the next part is the one I'm really familiar with, because I usually have large data sets to go with. Is childprocess.fork. Now this is slightly more, probably a couple years ago, but there used to be another way to do this, basically the same thing with this. But this was, and I'm kind of glad I re-looked it up instead of just grabbing some old code to do it the old way, because it probably wouldn't have worked when I started testing it. But basically all it's doing is code on the right is actually a separate file, right? You can see here just doing when you look in the for loop there, there's just a CP, which is childprocess.fork, giving it the path and the path.join for that, and then the actual file name for the file. All this is doing is basically it launches the file and starts it up as a separate node process running. So like if you were to like do a top or something, you're running this off a Linux server, basically you'd see, if you're on a quad-core PC at this point, you'd see 5 total Node.js processes, because you'd have the original one that launched everything, but that would be taking up minimal system resources, and then you'd have 4 other ones doing whatever you wanted them to do. But yeah, that's just console stuff out at the moment for that. So this one, runs a little more like you would expect it to like run, where it would just console log before the fork over there, and after the fork, and then just the children consoling out, because they're separate files. So it looks more like what you would expect when you're trying to launch other child processes. Here's a good example. I just pulled it out some code real quick on mine, how to pass arguments to something with fork. Because it actually looks just exactly like in a second, like you would parsing arguments out of anything that you started with Node if you wanted to do command line script for anything. So just basically anything after Node and then the file name becomes an argument that can be pulled by doing that. So this is just running that, forking that file, passing it an array of objects, or no, I'm just passing it a couple big arrays there, and then the file names basically. Another quick one that I threw up today that I had going. Oh yeah, this one was. If you look over here, I'm using async queue functionality to limit it. This right now, I'm going through and downloading. Oh, actually, on this one, it only says up to 200, but there's like 10,000 orders or something I was pulling off of a REST API that I had to download. So all I did is I set up queue, async queue to limit it at how many CPUs there were, so I wouldn't kill myself on there. Because if you're not careful with Node, you will bug the crap out of your PC and crash everything. Just because you'll kill all your memory. But just setting it up a quick for loop to push everything into the queue. We'll set the limit to how many cores that I had, and then over here is just doing the child start, giving it the URL, putting the ID of the URL, actually copying the file, and then writing it, or copying the order and then writing it to a file. It's pretty simple. And then exiting when it's done. So it's firing up every time it's downloading, but it takes a little bit, and it's like you'll just see a bunch of processes going up and down, and then, but it's quicker than doing it by with just one core. But anyways, guys, got any questions?
So you got a light, low-intensive memory process. You could use a multiplier number of CPUs, right? So you wanted to run basically 4-core CPU. You wanted to run 12 threads. You could run three forks or 3 clusters per CPU.
Oh yeah, if you wanted to. I mean, this is generally just the standard. You just do it off of how many CPUs you have. But because like for me, I'm usually downloading really big files or doing something with really big chunks of data, so I'm usually just limiting it to whatever core that I have. But yeah, you could have as many if you wanted to. I mean, the node process itself, yeah, you're going to get a little overhead every time you fire up a node process, but I mean, it's really lightweight comparatively.
The number of CPUs, does that track actual real hardware cores, or does it, my question is, where it's getting that number in the case of, say, an i7, where you have, so let's say it's a quad-core i7, but all those cores are hyper-threaded, is it going to read the number at 4 or 8?
It would read 8. Right. It does read the hyper-threaded on there. And you can actually, with the OS function on there, you can go down more and see the actual individual stuff on there. I was just grabbing a length of it real quick because it's an array to just get the number of how many cores I have. But like, if you need to, you could actually just do a loop, and if you just wanted like every physical core, not every like hyper-threaded core or whatever, you could do a loop through there and just find out how many are actually physical and not hyper-threaded. Then go for it.
Is it possible then to, I saw that you were just basically executing like other scripts off the different cores. Were there like, are you able to get the parameters or anything spits out of that back into the thread to like get back to the main process?
Yeah, actually, yeah, let me back up. I probably did let it go.
So like, could you like use like promises or something around that would, and
I usually just do events.
Sure.
If you see on here where it says, let me see the mouse, for the what's this child on message here? What this is doing is it'll fire up through the 4 forks or how many whatever it was there, and then it'll wait when you look over. I'm calling c.stop for because it's the new constructed there. You look down here to actually stop. I did. It's actually doing process.send.
okay.
And what that's doing is it's sending a message back to the master process that it is done.
Yeah.
And then it's executing the callback in the queue, so it goes on to the next one. And
So you're basically just using that separate script, and you get the parameters using the args or whatever.
oh yeah. Basically, they're just getting
Awesome.
handed the ID, and then it's just grabbing that order. Because the thing about this, it's a really crappy API. I can only pull 10 orders at a time out of there, and there's thousands.
Yeah.
So it's like, and it wouldn't let me move, like give it a range. So it's either I could pull 10 orders, the last 10 orders, or I could pull 1. So, and I didn't want to sit there all day. So
Yeah. Oh, I'm doing the same with trying to get like using a Git process for like libgit2 and JavaScript to like get a bunch of info out of a Git repo at once. You get basically thread bank pretty easily from some of that stuff. So it's interesting.
yeah. I mean, like I said, I usually use fork more than anything, but it saved me a lot of time. Like I've had to pull data out of, like the previous job I had at Data Realty I worked at was pulling like, it was like terabytes of data out of like Oracle databases and stuff. And like, I would have to write like most of it. Usually I could fit a table on the drive because there were these little boxes. They only had like, it was like 128 gig drives. And I only had it come up like twice where I couldn't fit a table on a drive before I rsynced it off. But it could get kind of messy with that. And then, but just doing it with just one process would just take forever. Have to go. And usually if it was smaller, I would just have each of them do different processes. So I mean, unfortunately I don't have any of that code because it was stuck at the old employer, but I had it set up in a way for basically, depending on how big the table was, you could go either have all the processes working on like different parts of one table, or you could have it do, each process doing a table, depending on how big the tables were. So usually it would be like it'd blow through like 1,000 tables or whatever. There were all the small ones, real quick, every process or core doing a table, and then it would get to a couple big ones at the end, and then put them all down. So it's really nice, it's really flexible, it's really easy for me anyways. I mean, it was a little weird at first, you know, asynchronous everything, but, you know, you get the hang of it eventually. And anything else, or any other stuff I need to pull up? I always hit up GitHub if I need be.